Welcome to the deep dive. Today we're looking at something, well, something we all do, learn.
Right.
Specifically, we're digging into this age-old question of how we actually learn best.
Yeah, is it better to just jump straight into a problem, or should you get the instructions first?
Exactly. It's a question I think everyone wonders about.
It really is. And it's fascinating because there isn't always one clear answer, is there? You probably remember times when just figuring it out worked great,
Oh, definitely.
and other times you were just lost without some guidance up front.
Totally. And that's why we're doing this deep dive today. We know you want to get to the heart of things efficiently without getting too bogged down.
Yeah, skip the fluff, get to the good stuff.
Right. Think of this as like your shortcut to understanding some really interesting new research. Research with practical takeaways for, well, all of us.
So our mission today is pretty straightforward. We want to explore what this recent study says about these two approaches. Instruction first, then problem solving, versus problem solving first, then instruction.
And the really interesting bit, how does what you already know change which approach works better?
Exactly. We're diving into a study published just this February 2025 in the Educational Psychology Review.
Okay.
It looks at two experiments, real classroom settings, university students learning about non-covalent interactions. That's a biochemistry topic.
Right.
And what's really neat is they compared two groups, intro biology students who had less prior knowledge,
Okay.
and biochemistry students who had more background.
So it's like a head-to-head test in the real world. Read the manual first or learn by doing.
Pretty much. Let's unpack these experiments.
All right, let's start with experiment 1. That was the intro biology student.
Yes, 367 of them. These were students considered to have, let's say, lower prior knowledge about this specific topic, non-covalent interactions.
Gotcha.
They split them into two groups. One group, let's call them IPS for instruction problem solving.
Okay, IPS.
They watch instructional videos first, then tackled problems.
Standard approach, sounds like.
Kind of, yeah. The other group, PSI, for problem-solving instruction.
TSI, okay.
They did the opposite. Try the problems first and then watch the exact same videos.
Okay, and non-covalent interactions. Remind me, that's like the tiny forces holding molecules together in biology.
Precisely.
Ugh.
Things like hydrogen bonds, van der Waals forces,
Yeah.
they're absolutely crucial for how proteins fold, how DNA works.
Right, fundamental stuff. But I remember finding it a bit abstract.
It can be, definitely. That's why the researchers chose it. It's important, but often a tricky concept for students starting out.
So how did they measure learning?
Well, everyone took a pretest to check their baseline knowledge.
Okay.
Then after the whole intervention, the videos and the problems, they took two post-tests. One was near transfer.
So meaning problems similar to what they'd practiced.
Exactly. And the other was far transfer problems, needing the same ideas but in a, more different or novel context.
Okay, so that PSI group, the ones tackling problems first, were they just like thrown in completely cold?
Not quite. They got problems asking them to predict effects of, say, changing an amino acid on these interactions. The key was they were prompted to think about what they might already know that could be useful and just try to generate ideas, even if the ideas were wrong.
Ah, so the goal wasn't getting it right immediately.
No, not at all. It was about activating their thinking, getting them engaged with the concepts before the formal explanation.
Right, like trying to build IKEA furniture without the manual first. You start seeing how bits might connect.
Yeah, something like that. And what about the instruction? What were those videos like?
They were a 4-part series, explained the different forces, the role of charge, and walked through examples step by step. And interestingly, they specifically addressed common student mistakes or misconceptions. That's clever.
Yeah, so you can imagine for that PSI group who just struggled, seeing those misconceptions addressed could be powerful. Like, that's why I was confused.
Real aha moments, potentially. Okay, so we've got this set up for experiment 1. Lay the findings on us. What happened with these intro students?
Okay, first off, the pretest showed both groups started pretty much equal. No significant difference in prior knowledge. Good sign for the experiment.
Right, fair start.
Now, during that initial problem-solving part, the IPS group, the ones who saw the video first,
Yeah.
they actually did better. Solved more correctly, generated more ideas than the PSI group who hadn't seen the video yet.
Okay, that seems logical, I guess. They had the instructions.
It does seem logical. But here's the twist. After everyone had watched the videos, the PSI group, the ones who struggled first, They scored higher on quizzes about the video content itself.
Whoa, really? So struggling first made them learn the video content better?
It seems like it. Like that initial effort made them more receptive, maybe, more ready to absorb the explanation when it came.
That sounds like that whole productive failure idea. Struggling makes the eventual learning stickier.
Exactly. And the biggest finding really backs this up. On that near transfer test.
The similar problems.
Yes, the PSI group struggle first significantly outperformed the IPS group.
Wow. Okay, so for problems like the ones they practiced, struggling first paid off for these beginners.
Definitely seemed to. They were better at applying what they learned to similar situations after that initial wrestle.
But what about the FAR transfer test, the really different problems?
Yeah. Interestingly, no significant difference there.
Hmm.
Neither group seemed to have an edge when it came to applying the concepts in a truly novel way.
So the benefit of struggling first was kind of specific to the types of problems they'd encountered.
It appears so, based on this experiment.
What did the researchers think was going on? Why did that initial struggle help the PSI group on the near transfer?
Their thinking was that the struggle likely did a couple of things. One, it activated whatever little prior knowledge the students had. Two, and maybe more importantly, it highlighted what they didn't know. It showed them the gaps.
Ah, so they knew what to look for in the video.
Exactly. They were primed, more receptive to the instruction because they'd already identified their own confusion. They were ready to fill those gaps.
Makes sense. Okay, that's fascinating for novices. Let's pivot to experiment 2. The biochemistry students. More knowledge coming in.
Yep, 138 undergrad biochem students. Same procedure. IPS versus PSI, same tests.
And they definitely knew more beforehand.
Oh yeah, the pretest scores were significantly higher than the intro bio group, confirmed they had a stronger foundation.
Okay, so what happened with this more experienced group? Did struggling first help them too?
Well, let's break it down. First, just like experiment 1, the two groups within the biochem cohort started with similar prior knowledge levels relative to each other.
Great. Fair comparison again?
And also, similar to experiment 1, during the initial problem-solving phase, the IPS group instruction first did better. More ideas, better performance.
Okay, so getting instructions first still helps with tackling the initial problems, regardless of background knowledge. Consistent.
Seems so. But here's where it flips. Remember how the PSI intro students did better on the video quizzes after struggling?
Yeah.
With the biochem students, it was the opposite. The IPS group instruction first scored significantly higher on the quizzes right after the video.
Whoa. Okay, wait. So for these students, struggling first actually made them learn less from the video.
That's what the data suggests. It's a really key difference.
Why? Why would that happen? Any ideas?
The researchers hypothesized that even though these students knew more general biochem, they might not have had solid strategies for these specific non-covalent interaction problems.
Okay.
So the initial struggle without a clear path forward might have been more frustrating, maybe even confusing or misleading for them.
Instead of productive failure, it was just failure. Or maybe confusing failure.
Potentially less productive, certainly. It might have increased their cognitive load or even led them down incorrect paths that made it harder to then absorb the correct information from the video.
So that struggle didn't prime them, it possibly hindered them.
It seems that way, at least for learning from the immediate instruction, and this pattern carried through to the near transfer test.
Ah, the big one. What happened there?
Direct opposite of experiment 1. For the biochem students, the IPS group instruction first significantly outperformed the PSI group on near transfer.
Wow. Okay, so for students with more background, getting the clear explanation before trying similar problems was better.
Exactly. It aligns more with ideas like cognitive load theory, if you have some relevant knowledge structures. Giving you clear instruction first helps you build on them efficiently without the potentially overwhelming initial struggle.
This really paints a picture of it depends, doesn't it?
Absolutely. No single best way.
Correct.
What about FAR transfer for the biochemists?
Same story as the intro students. No significant difference between the IPS and PSI groups.
Still elusive, that FAR transfer.
Seems like getting people to apply knowledge flexibly in new situations is just hard, regardless of the initial learning sequence.
Very much so. These interventions were likely too short or not designed specifically enough to really foster that deep, adaptable understanding.
Okay, so let's zoom out. We've got these contrasting results. PSI better for novices on near transfer. IPS better for those with more knowledge on near transfer. No difference on FAR transfer. What's the big picture takeaway?
I think the core message is that the optimal sequence instruction first, or problems first, really seems to hinge on the learner's prior knowledge level.
Right.
If you're new to something, that initial grappling, that productive failure, can genuinely help you learn better from subsequent explanations, at least for similar tasks.
Bud.
But if you already have some foundation, maybe not expertise, but some relevant background, getting clear instruction up front might be the more effective and efficient path to mastering those kinds of problems.
It's such a nuanced finding. It doesn't neatly fit into just one theory, does it?
No, it doesn't perfectly align with just productive failure or just cognitive load theory. The intro student results support productive failure, but the biochem student results lean more towards cognitive load, suggesting instruction first is better when you're not a total novice. It's messy.
The real world often is. Could other factors be at play, like how the students approached it?
That's a great point the researchers raised. Maybe the intro students were more open to just exploring during that initial problem phase. Less pressure, perhaps.
Yeah, maybe seeing it as just figuring things out.
Whereas the biochem students, maybe they felt they should be able to solve it because they had more background.
Right, and then struggling could feel more frustrating or discouraging.
Exactly. That feeling could definitely impact how much they then engaged with or learned from the instruction video. Mindset matters.
Makes total sense. If you feel like you're failing at something you think you should know, it's easy to tune out.
Absolutely. And again, the consistent lack of difference on FAR transfer is telling. It just underscores the challenge of teaching for really deep, flexible application.
So, practical advice for listeners trying to learn something.
I think it encourages being more mindful of where you're starting. If it's brand new territory, maybe lean into the struggle a bit first. Try things out, see where you get stuck before looking up the definitive answer or tutorial.
Let that struggle guide your learning from the explanation.
Right. But if you're building on existing knowledge, maybe in a more advanced course or skill, then seeking out clear structured instruction first might save you some frustration and be a more direct route to applying it correctly.
But with a big caveat.
Huge caveat. This is one study-specific topic. The quality of the instruction, the quality of the problems of those things are probably paramount. Just flipping the order isn't a magic bullet.
Good point. And the study had limitations too, didn't it?
Oh, definitely. The researchers were clear about that. Grouping by course level isn't perfect for prior knowledge. There's overlap. The videos were watched out of class, so less control over engagement. Problem solving was individual collaboration could change things.
And it was just one topic, one short intervention.
Exactly. Biochemistry, non-covalent interactions, short time frame, lots of variables still to explore.
So where does the research go from here?
Well, they suggest looking at a wider spectrum of prior knowledge, not just two groups, exploring different learning environments, motivation, collaboration.
Different subjects too, presumably.
Yes, and longer studies. Does an initial advantage for IPS or PSI hold up over a whole semester, for instance? Lots more questions.
Okay, so wrapping this up for our listeners, the big takeaway seems to be that best way to learn, it's complicated.
It really is. It depends on you, on what you already bring to the table.
Yeah.
No single formula.
We saw that sometimes, yes, struggling first can be really beneficial, especially if you're starting out. That productive failure idea has merit.
But we also saw that sometimes having that prior knowledge means getting clear instructions first is actually the better bet, avoiding unpredictable frustration.
So, for everyone listening who wants to learn effectively and who doesn't, this really highlights knowing yourself. Be honest about your starting point.
Yeah, and maybe experiment a little. If it's totally new, try wrestling with it first. See if the explanations click better afterwards.
But if you've got some foundation, maybe don't feel bad about seeking out that clear explanation up front. It might just be the faster path for you in that context.
Which brings us to a final thought to leave you with. Think beyond the classroom. How does this play out elsewhere? Learning a new software, a work project, assembling that furniture we joked about.
Right. Do you dive in or read the manual? Does your existing knowledge or lack of it sway that choice?
And what does it really mean to have just enough knowledge where that initial struggle stops being productive and just becomes confusing? Something to chew on.
Definitely something to ponder. And hey, if you really want to get into the weeds, the researchers made their data public on the Open Science Framework.
Very cool. Well, this has been a really interesting look at the nuts and bolts of learning.
Absolutely. Thanks for joining us on The Deep Dive. We'll be back soon to explore another topic.